По кейсу?
Да.
По кейсу можно, а так нет. В чем?
А у нас прямо вот точно-точно должны совпасть?
В интерполяционном методе? Да.
Ну, потому что вы показывали, что шаг не очень большой, а вот у нас при увеличении шага...
Я говорила, что нужно сделать, если они не совпадают. Я на этот вопрос уже отвечала. Серьезно. Нет. Ну, нет. Ответ на ваш вопрос нет. От того, что вы больше возьмете, у вас все равно не совпадет. Но вы можете его уменьшать, конечно, наверное, почти до бесконечности, но я боюсь, что это не приведет к нужному результату. В принципе. Там это вообще не требуется. Там, если вам повезет, они, конечно, подтянутся. Не подтягиваются так или иначе, но это же не интерполяционный метод. Интерполяционный многочлен предполагает полное совпадение в узлах. Это его методика построения. Но мы, в принципе, с первым кейсом закончили, поэтому я не вижу оснований к нему возвращаться. Что, мы будем во второй играть?
Еще не подскажете, есть ли какие-то критерии для выбора акций?
У вас они должны быть в той же валюте и на той же бирже, что и облигации. Это я написала. Все.
Еще такой вопрос. Если облигации брали из нескольких бирж,
Акции вы в любом случае берете с одной биржи, потому что для того, чтобы их оценить, их нужно будет сравнить с рынком. А показателем рынка является индекс. У каждой биржи свой индекс. Поэтому брать акции с разных бирж нельзя. Поэтому если вы брали облигации с разных бирж, вам акции нужно брать в той же валюте, что и облигации, но с одной биржи. Антонова, Баранова, Гончар, Грачев, Гришина, Карапетян, Лиманов, Костельникова, Савелов, Савин, Серова, Калова, Тимонина, Трифонова, Трушев, Карп, Хромова, Шейхова, Шеникина, Лимашев. Балонкин, Велищук, Гарпуша, Давыдов, Ефимович, Жуганова, Зайцев, Исаева, Инженеров, Кофтон, Коренев, Елисавец,
Я.
Мызина, Науменко, Окрокова, Полякова, Сергеев, Стрелов, Троицкая, Азов, Чудотворова. Значит, вы из 10 группы, у вас там есть волшебные люди, которые оформили свои свободные посещения. Вот я им отработку не поставлю. Передайте, пожалуйста. За то, что они не могут 2 кнопки нажать, вообще не вопрос. Но просто можете в группу кинуть информацию, не знаю, кто это. У вас тут 3 человека таких, и их сегодня нет. Если человек не может нажать 2 кнопки, будем подходить формально. Ну, свалится, ну что могу поделать? Ладно. So I think you know from the previous year, switch case number 3, it includes 3 parts. 2 of them are about loans, and the third one is about risky assets. In your case, it will be 7 shares. Actually, it will be a portfolio of consists of these 7 shares. We will start with bonds because you're already a bit familiar with asset. You already started some information about it when you deal with the case number 1. Okay, first of all, we will study some properties of this particular asset. And then we will study 2 strategies of management of bond portfolio. One of them will be active strategy, and the second strategy will be passive strategy. After that, we will proceed to the direction of risk asset, and then we will form a portfolio of risky asset, and then we will form the combined portfolio. This is very, I think it's a very common information about case number 2, but I think it's enough. The key difference between your case and the case of the previous year that you will construct a real combined portfolio, and when you will unite in one portfolio risky and risk-free asset. Okay, first of all, we will study basic numeric characteristics of the bond. Each bond has 2 key characteristics. First is duration, or monthly duration. This is a particular number calculated by the formula number 1. You can see it on the slide. So if interest is accrued m times per year, or coupon payments happen m times per year, duration, or monthly duration of the bond is calculated by the formula number 1, where CTK represents coupon payments, or the last payment, it will be face value plus coupon payment. R represents the internal rate of return. So pay attention that in case you want to calculate the duration, first step will be to find the internal rate of return. And after doing this step, you will be able to find this very important characteristic. Okay, so here P represents the current price of a bond. Okay, what should you know about the duration of the bond? You can write in your exercise book some properties of duration. Property number 1 is that the duration will always be less or equal than the maturity of the bond. Actually, it will be equal in case of purely discount or zero coupon bonds. So in case you have, or in case the bond has only one future payment, the duration will be equal to the maturity. Otherwise, it will be less than the maturity. Pay attention also that this number is always positive. The duration of cash flows depends not only the structure of these cash flows, but also it depends of current rate. You can see it on the slide. Pay attention that the rate is in numerator, is a denominator, so it means the higher will be the rate, the less will be duration. And also it depends on time. So the higher, the long distance payment compared to short will have the less duration, and vice versa. Also, the lower will be the rate, the more will be the duration of the cash flow. Okay. If you hear the phrase that your bond duration is equal to, for example, 3 years, it means that the bond has the same price sensitivity to fluctuations in rate as 3 years zero coupon bond. Do you understand me? Okay, good. Another interpretation of the duration is it represents the average or weight, also called weighted average number of years that the investor must hold the bond to get the discounted cash flow of the bond. So that the discounted cash flow of the bond be equal to the price he paid when buying a bond. Do you understand me? So this is the narrow interpretation. Duration is the average number of years the investor must hold the bond, so that the discounted cash flow, this discounted cash flow be equal to the sum he paid when he bought the bond. I can go to Russian if you want.
You can.
I can. You want? I go to Russian.
Yeah.
Or no need to do it. Но не за 3 года, а за сколько получится. Да, когда ваши деньги вернутся обратно. Понятно? Но деньги, которые вы заплатили в момент покупки. Понятно это? Duration is a very important characteristic of cash flow because and it determines the sensitivity of the current price or present value of this cash flow to changes in interest rates. Duration allows to estimate the degree of dependence of the market price of the instrument to changes in interest rate. The more duration of any financial instrument, the more will be change in market price when interest rate will change. And the higher will be the interest risk. Do you understand me? Shall I repeat? The more duration of the bond, the more will be change in market price when the interest rate will change. And the high, and as a conclusion, you can make the conclusion that in case the risk, the interest rate risk will be higher. So it's direct dependence between duration and interest rate risk. Another characteristic of the bond is so-called modified duration of the bond or adjusted duration of the bond. So to calculate it, you should calculate duration when divide the result to the factor 1 plus r divided to m, where r represents the interest, the internal rate of return, or the yield to maturity. We are supposing that interest is equal to m times per year, or coupon payments happen n times per year. Modified duration is an indicator characterizing the reaction of bond price to change in yield maturity, not in rate but in yield maturity. In case we have small changes, we can use the approximate formula So you can find the relative change using the formula on the slide, when you can just modify duration to change in rate. It means if you do not want to recalculate everything, you know the initial numerical characteristic, and you know that the changes in rate have happened, so you can make an assessment and you can calculate the estimation of change in price of the bond using the formula on the slide. Let's consider the example. Let the modified duration be equal to 4. Let the modified duration be equal to 4. The bond is trading at price of 80% of face value. The yield to maturity is 8%. Accrued interest is 0. One more time, modified duration is 4. Bond is trading at price of 90% of face value. Yield to maturity is 8%. Accrued interest is 0. The question is, how will the price change if the yield to maturity rises up to 8.5%? So we know that yield to maturity or internal rate of return, it was equal to 8%, and now it rises up to 8.5%. So actually it means if you want to apply this formula with delta L, change in rate will be out of 1%. It means 0.005. Okay? I think it's clear. So if we want to apply this formula, and if we want to calculate the changes, how it can be done, delta P, it will be equal to а там минуса нет, что ли? Так, вот здесь минус должен быть. Sorry. Вот сюда минус надо поставить. Итак. So in this case, you will get, it will be minus 4 multiple to, we know it is 90%, 80% of face value. And change in rate is 0.005. So you can multiply, how much is it? Yes, it will be negative, so it will be minus 1.8%, because it's 8% of face value. So what does it mean exactly? It means that price will go down to this value from the current price. So we know that the current price is equal to 80% from the face value. And now, after the internal rate of return will go up to 8.5%, the current price will be equal to 88.2% of face value. Okay, it goes down because the internal rate of return goes up, and we have the inverse relation between current price and internal rate of return. This formula allows to calculate change in price. Change in price without doing estimate, not the exact value, but you can estimate, but it's a good accuracy, but in case rate changes slightly, you can estimate change in price in bond. in bond without recalculating everything. If you want to make a fast assessment, you can use this formula. In case you want to recalculate everything, of course you can do it, no problem. Okay, let's move to the next very important characteristic of a bond. This is the second very important characteristic of a bond. It calls convexity. So you can see if we will compare it to the previous characteristic, we added one more factor, t plus 1 divided to m. So this is the convexity of a bond when calculating interest m times per year. I have written that this number is positive. In our case, yes, it will be positive. What is the convexity valve? You can make the special notation that convexity measures the degree of change in duration of a bond depending on fluctuations in interest rates. Convexity measures the degree of changes in the duration of a bond depending on fluctuations in interest rates. For non-repaying bond, where it's our case, which is why I have written positive. For non-repaying bond, convexity will be always positive because the yield does not affect the payments of the bond. In case of callable bonds, the payment will change, and in this case, the duration will decrease when the rate will increase, and the result will be the negative convexity due to the form of the yield curve. Negative convexity can happen in case of revocable bonds and I think in case of revocable bonds. Okay, so at this moment you know that the convexity is very special parameters. How to use it? Bonds with more convexity. In case the convexity characterizes change in duration, so the more convexity you have, what can you make as a conclusion? Yes. And what does it mean for the holder? If you're a holder and if you want to compare the bonds with, so you are comparing two bonds, we have the same characteristic, but the convexity of the first one is more than the convexity of the second one. How does it influence your choice? First of all, you have to pay extra because you will have an additional advantage. The bond will be more volatile, so you have an additional advantage when trading with bonds. You can earn more, which is why you have paid more when buying such a bond. Okay. Okay, so I think we had discussed two very important characteristics of the bond. Duration and the convexity of the bond. Now we are arriving to notation to the cost of investment in a bond. When you have formed a bond portfolio or you have bought a bond, the question arises how much did you earn
after 5 years, 4 years, 3 months, after sometimes that had happened when you have bought the bond portfolio or just a particular bond. To estimate this, we will study the notation of the cost of investment in a bond. This notation has two assumptions. Assumption number one, pay attention that I'm considering only a bond but not a bond portfolio due to the fact that a bond portfolio can be recalculated to a particular bond. So no need to use a portfolio of the bond. Do you understand me? Yes or no? In a few minutes, we will study how it can be done, which is why it just the point of interest how to assess the cost of investment in a bond. So the assumption number one, we are assuming that all the coupons until the time t when you have decided to make the assessment of your investment are reinvested. It means you got the coupons. We are assuming that you are investing this money to the corresponding risk-free rates at the moment you got them. So you are not spending this money. You are not just you're just putting all the money to the deposit using corresponding risk-free rates. And at the moment of assessment, you are the bond, you are selling the bond. This is this assumption number two is just to make the assessment of current price. Okay, let's consider an example. And this is how to make the assessment. So we have a bond. We bought a bond. This bond at the moment of purchasing, it has 4 future payments in 1, 2, 3, and 4 years. And in 4 years, it has the date of redemption, but it does not influence the result. In 2.5 years, we decided to make the assessment of our investment. So how it can be done? If we will go to the theory, we will have the following situation. What is the situation? So, here you have bought a bond. In 1 year, you got the first coupon. In 2 years, you got the second coupon. Here, at 2.5 years after buying the bond, you decided to make the assessment. And at this moment, you have 2 future payments, this one and this one. Is everything clear? Okay. What does it mean? According to the theory I have shown you a few minutes ago, these 2 coupons must be reinvested. So here you have how much time period? How much is it? 1.5 years, yes? So this coupon will be invested for 1.5 years at the moment you got it. So it was in 1 year, and the duration of the investment is 1.5 years. So it means the rate will be 5%. Do you understand it? The second coupon you bought will be reinvested for 0.5. So here is 1.5, here is 0.5 years. And here, if you want to make the investment for 0.5 years, the rate will be equal to 6%. Do you understand me? Actually, what does it mean exactly? Exactly, it means that you should make the investment of this coupon under this rate for this period of this coupon under this rate for this period. How to calculate the result? Using the formula of financial mathematics, elementary financial mathematics. The formula is to the initial value, 1 plus nominal rate divided to m, and n to m. M in this formula will represent the number of times when accrued interest, and is the period in years. This is the nominal rate. This is the initial deposit. Any questions? So it looks like the formula for the present value, but instead of dividing, you are multiplying this factor. Do you understand it? The idea absolutely the same. Okay, if we want to calculate the result of this part, it will be equal to it will be the sum x1, the first part about the reinvestment. The first coupon is 100. We had discussed it is reinvested under the rate of 5% plus 0.05. According to the task, we can see that interest calculating twice per year. So it means m is 2, so we should divide it on 2. Then the time period for the first coupon will be 1.5 years, and multiple to m, which is 2. This is about the first coupon, and about the second, it also equal to 100. When multiple 1 plus the rate, the second rate we had discussed it, is equal to 0.6 divided on 2 because m is 2, and the duration of the period is 0.5 to the second coupon, and multiple to m. So this will be the result of our investment of 2 coupons. Any questions? Because if you will go back here, you got the coupon in 1 year at this moment. At this moment, the risk-free rates for the investing for 1.5 years is equal to 5%. Can you see it? When you got the second coupon, it was in the year number 2. So the duration of the investment of this coupon is 0.5 years, and the rate for this investment is 6% per year. Okay. Okay. What next? Next, we should calculate the present value of the bond. What's the problem in this case? We do not have the current price. We are not able to calculate the internal rate of return and calculate the present value of the current price using the formula you got on case number 1. But you have the term structure. In this case, you can calculate the present value using term structure. How it can be done? At this moment, you have 2 future payments when you want to make the assessment of the bond. You have these future payments. The discounting period for this future payment is 0.5 years. And you also have this future payment, and the discounting period for this payment is 1.5 years. Okay? But you are discounting at this moment. You are not moving in time, so to get it, you just use the same formula, CTK, divided 2, but instead of R, internal rate of return, you will use the term structure. And you will get 1 plus R1 divided to M. This will be the first rate. T1 multiple to n, and etc. Next payment will be about R2 and T2. Let's go to the slide. At the time moment, 2.5 years, the risk-free rate for investing for half a year is equal to 6%. And the risk-free rate when investing in 1.5 years is equal to 7%. Can you see it? What does it mean exactly? It means that if you want to calculate the sum S2, it will be equal to the following construction. The first future payment is the coupon number 3, it's equal to 100, divided to 1 plus the first rate is 0.06, m is equal to 2, and the degree is the duration of discounting period 0.5 multiple on 2 because m is 2. This is about the first coupon. Next, you will take the second coupon and the last one about this bond. It will be 1,100 multiple divided on 1 plus rate, corresponding rate is 0.7, divided on 2, and the rate is equal to the duration of the period 1.5 multiple on 2. So you will have this sum. And to find the cost of investment, you should summarize them. It means you should add to this sum, you should add this sum. So when you are holding a bond portfolio, now at this moment you are ready to make the answer of the question, how much money do you have at any moment of time after the purchasing? And I will ask you pay attention, and you at this moment you must be able to make this assessment. Any questions? Okay. Что означает? Okay. Did you understand how to calculate the current price in case you do not have it or not able to calculate the internal rate of return? You should use the term structure. Okay. This is the second opportunity to make the assessment. Okay. Now we are arriving to very important notation. The notation number 1 is about the estimated cost of the investment in the bond. If you have a bond portfolio, of course, you are planning to earn the money. How to estimate, how to make the not senseless assessment about the sum you want to earn. At the moment you are calculating, you have the current price of the bond, and you have the rate corresponding to the risk-free rate for this time of investment from term structure. So you just using this formula of financial mathematics to make an assessment. It's very clear. And it gives you the estimated or the planned cost of investment. So you are planning to earn this amount of money. Did you understand how to make the assessment? So, for example, you are planning to hold a portfolio for 3 years. You can, at the moment you want to make the assessment, to find the rate on zero coupon curve, for example, corresponding to this time period, and then you know the current price and you are able to calculate the result. Okay.
Can I ask you?
Yes.
In previous slide, and so we solved a task where did we divide this calculations into parts? So we have S1 and S2 because we divided this.
Because we want to calculate the cost of investment after buying a bond. You have bought a bond, and in 2.5 years after buying a bond, you decided to make assessment.
Yes.
But this construction works when you just have bought a bond and you just planning to earn something.
So we don't.
You didn't bought at moment, just planning to do it. You're planning to buy a bond P, the bond which has this current price. And the question is how much money are you able to earn? And to estimate this sum of money, you should multiply this current price with this factor to make an assessment of your future earnings. Okay? And it will give you so-called estimated or planned cost of investment. Okay? So the difference is that in the previous situation, you have bought a bond, and after some period in time, you decided to make an assessment. And here we are talking about our future earnings at the very beginning of our investment. Okay, so this is a called plan cost of investment. Of course, if you are an investor, you are calculating this number. But of course, in real life, the rates will change. You understand it, because at the moment you are planning to make an investment, you calculated this number, but in real life, the rate will change, and you have so-called actual or fact cost of investment. So the rate will change. You have to recalculate the current price using this rate, and you have to recalculate the cost of investment. And actually, at this moment, you understand that you have two different sums. They can be different slightly, or in some cases, the difference between these two sums can be significant. Do you understand me? Due to the fact the rate had changed. Okay, what shall we do in this case? In this case, we should just calculate moment in time when our planned cost of investment will coincide with our fact cost of investment. You can find this time moment. Actually, what does it mean exactly? I will explain you. I will try to explain you in simple words. Let's discuss what do you see right now on the slide. So let us suppose you okay, so you are planning to earn in T years, you are planning to earn, I don't know, P1. But the rate had changed, and now you have to hold the bond this time. It can happen that this this new TU will be here, or it can be here. It depends on the direction in changing the rates. I'm talking about if they go up or go down. So it can happen that you have to buy here or to sold here. You want to earn this money, or maybe you have to hold a bit more to get the same price. But the key idea is that you can achieve your goal. You can get it. You understand me? Despite the rate had changed, you can get this amount of money you are planning. But it just means some changes in holding period. Do you understand me? Okay, this formula is about this construction. This is how to recalculate holding period to get the money you are planning to earn at the very beginning. Okay? This is not unusual situation, but this is the idea of the so-called immunization strategy we are going to implement in your case. So you can see that despite the changes in rates and despite the changes in current price in bonds and so on, you can get the planned sum. But you have to change the holding period, but the result will be you will get the sum you're planning. Okay, so this is this was the approaching to immunization strategy. First of all, we will consider so-called immunization property or immunizing property of a bond. We have a bond. We know it has future payments, CT1, CT2, and CTN. At the time moments T1, T2, and Tn. And now you can see the theorem, so you can find the proof of this theorem, I think, in the book of Fabozzi or in the book of Sharp. The theorem tells us that if we have the number dm, which represents the duration of our bond, at the initial moment of time, when the rates are equal to m, then at the time moment, which is equal to this duration, the actual cost of investment in bond at any, pay attention to this words, at any risk-free rate will be not less than estimated cost of the investment. This is very important property. What is this theorem about? So at the very beginning of our investment, we are calculating our estimated sum of the investment. When we are not going to take into consideration if rates had changed or not. The key moment is that if the holding period is exactly equal to the duration, you will calculate at the very beginning of the holding period. At this moment, the actual cost will be not less than the planned cost. Did you understand what had happened? The key moment, it does not influence in which direction will go the risk-free rates. We are not interested in it. At this time moment, our actual cost of investment will be not less than planned cost of investment. So this is how to achieve the bond, how to reach the goal. Any questions? Did you understand what had happened? This is very specific property only about very specific asset, which is the bond. And this is the idea which lies on the base of immunizing strategy we are going to consider. But before we will go to the strategy itself, I will explain you how to recalculate the bond portfolio in a particular bond. Let us suppose we have some bonds, P1 to PL, and we are planning to invest the sums from omega 1 to omega L in corresponding bonds. This means I'm planning to invest the sum omega 1 to the bond number 1 and omega L to the bond number L. I think it's quite clear that in this case, the coupons will go with corresponding weights. So if I have this fraction represents the number of bonds I will bought after investing the sum, and this number should be multiple to the corresponding coupon. Yeah, if at the time moment T1, the bond number 1 will not pay the coupon, for example, this factor will be equal to 0, and so on. So this is the general formula to recalculate the bond portfolio to a particular bond. Now, to clarify it and to make it useful, we will consider a particular example. Let's do it. So we have three types of bonds, A, B, and C, with some future payments and some dates of redemption. And we are planning to invest 2,000 in the first bond, 4,000 in the second, and 5,000 in the fifth. Okay, let's do it. Okay, so I have 0.5. This is the time period, so 1, 1.5, and 2. The current price is, so it's TK. And now let's consider future payments for the first bond. All of them are equal to 50. And the last one is 1,050. For the second bond, it pays coupons. So here we considering it pays 0, and here will be 100, and here will be 1,100. Here 60, and 1,060. Okay, so the current price of each bond is equal to the first one is 1,000, to the second is also 1,000, and here is 1,050. The planned sum of investment is 2,000, 4,000, and 5 to the third one. Okay, let's do it. Now we should recalculate the payments in 4 time moments, 0.5, 1, 1.5, and 2. So CT1, it means CT, I don't know, let's make like this, CT 0, 0.5. Okay. But from our portfolio, you can see that the sum of investment in the first bond is equal to 2,000. The current price is 1,000, so this fraction gives us the weight, and then we should multiply it to the coupon. The second bond will not pay anything at this time moment. That is why we are going to the third one. This is the sum of the investment in this bond. It has the current price equal to this number. This fraction gives us the weight, and we should multiply it to the corresponding coupon. Okay, but I think you understand that it is just a mathematical sum and nothing else. Because in real life, if you will divide this to this, you will be able to buy just 4 bonds. Do you understand it? So when you will solve this part of the case, you will solve it in 2 directions. In first direction, you will use just mathematical approach. In the second way of the solution, pay attention to this fact, because you should represent 2 solutions. You should make real calculations. Do you understand me? Because here it means you do not have enough money to buy 5 bonds and you are buying 4. Okay? What's about the next future payment? It's about time moment 1. In 1 year, we can see that all the bonds will pay. So this number will represent the weight for the first coupon. For the first bond, the coupon is 50. This number will represent the weight for the second bond. The coupon will be 100. And this number will represent the sum for them, the weight for the third bond. And here the coupon is 1,060. Next will be the time moment CT 1.5. What do we have at this moment? Only the first bond will pay something, so we are calculating the weight in the portfolio, and we are multiplying to the corresponding coupon and get the result. And here, the last time moment in 2 years, here we have the payments for the first and for the second. The weight for the first is 2,000 divided to 1,000, and we are multiplying to the corresponding coupon, and plus the weight for the last one, divide to corresponding coupon, or multiple to the corresponding coupon, sorry. In real life, you have to make an adjustment. Here, no problem, because here the weights will be 2 and 4. But in real life, when calculating this time moments, you should make an adjustment because you are not able to buy this part. Actually, it means here you should make some changes, and you can use a function like this. Like this. And the sum will change. I think you see. But if you, and here you can do absolutely the same. We have the same third bond, and it has a problem here, so we should use this construction. And I think everything is clear, because this is the real situation. You are not buying, you are not able to buy in real life 4.7 bonds. In this case, you understand that the sum of the investment in real life will be how much if you are buying for bonds for this price. In real life, the sum of investment will be equal to this number multiplied to 4. So you should add this one, and this one. It will be equal to 10,020. You understand me? 10,200, yes? But if you are summarizing all of them and make mathematical calculations, the sum of the investment will be equal to 11,000. And the coupons will be different. So in your case, in the first approach, you will use, when realizing or implementing immunization strategy, you will use just mathematical calculations and everything will be okay. Then you will adjust the strategy to real life and everything will not be okay. Did you understand the difference? Okay, but the key idea about this construction is that instead of considering, in both ways, instead of considering the bond portfolio, you can consider the bond. For example, if we go to real life, this bond will have the current price equal to this. This is the sum of the investment. This will be the current price of the bond. And future payments of this bond will be equal to 140, 4,740, 100, and 6,500. Very special bond. Any questions? Yes, this is one bond you will consider instead of one portfolio. It's just the same. For this bond, yes, you can, because you have current price and future payments. And you can see that payments happen 2 times per year, so it means M is 2. So you can calculate internal rate of return and all the characteristics of this bond, like duration, convexity, everything. The key idea that you are calculating a portfolio to a particular very specific bond with different payments, but no problem to do it. Okay?
And what if our coupon payments are not on the exact same day, but they are different?
You have to consider all of them.
Okay.
It's just frequency of coupons will increase. And here you are supposing the coupon payment is 0, as I told you.
Okay.
That's all, just frequency of your new bond corresponding to your portfolio will be more than the frequency of particular bonds which are in your portfolio. Okay? Any questions at this moment? Okay. Какой момент? Настя спросила, что если они не совпадают. Я сказала, что ничего страшного, значит, у вас частота возрастет. Ну, допустим, первый бонд у вас платит купон 20 января, а второй 23-го. Ну, вы их рассматриваете отдельно.
То есть вот нужно ноль поставить, да?
Да, да, нули, ну не одному, а кому там надо, там у вас почти у всех будут нули. Да.
Просто она будет больше, получается.
Она будет больше, у вас фреквенси возрастет просто и все. Не, ну у вас она не возрастет, потому что у вас же они там все с одинаковой фреквенси, вроде как. А у вас, вы банды выбирали с одинаковой фреквенси, ну тогда она у вас такая и останется. Она у вас останется с 2 раза в год. Понятно, что я говорю? У вас просто они сдвинуты, эти выплаты, а М у них у всех какое было, такое и есть. Но если у вас оно с разным М, то оно у вас все в непрерывную ставку считается. Но идея именно такая.
Если они у нас разные не выплачиваются, то
Ну а какая разница, они у вас выплачиваются в разные дни, они у вас и изначально в разные дни выплачивались, а М у всех было 2. И что?
тогда
Чего не нужно?
0
0 нужно проставлять. Потому что 0 соответствует дате. Вот здесь вот этот не платит купон. Вы все равно считаете, что вот этот купон, что вот эта облигация работает с купоном с фреквенси 2. Раза в год она делает пеймент. Только один пеймент у нее 0, и второй раз у нее 100. Вот и все. Да, для чистоты. У вас у каждого банда так и будет. Но куда-то вы доставите там им нули, вот в эти куски. Ничего страшного, мир не рухнет от этого.
Ну, то есть, если по одному выплачивается 20 января, а у второго, допустим, 22,
То будет и 20, и 22.
значит, когда мы будем строить эту таблицу,
Вам хорошо будет, да.
нужно будет нули.
А?
Я говорю,
Нужно будет нули проставлять, да.
Хорошо.
А в Excel можно ничего клеточки не ставить, и там будет 0, прикиньте. Он так умеет.
И плюс нужно будет общую сумму инвестиций пересчитывать, когда мы будем делать вторым подходом.
Вам 2 подхода надо будет сделать, да. Ну, в одном у вас все хорошо сойдется, все будет работать, а во втором, когда вы попытаетесь на практике это применить.
Да, так целое число облигаций можно.
Ну, 1,5 облигации купить нельзя.
И поэтому общая сумма инвестиций должна быть.
Ну, либо вы можете добить и увеличить, и у вас будет выбор. У нас демократия, свобода выбора, Шунейкина. Можете купить 5 бандов за, не знаю сколько, 5,250, или я неправильно считаю? Правильно. И тогда будет 11,250. То есть вы можете сказать изначально, что вы докладываете. Угу. Там во втором подходе все будет очень весело. Вам понадобится счет с деньгами, иначе все будет очень плохо. Понятно? Второй подход называется «Добро пожаловать в реальный мир». В реальном мире нельзя купить, нельзя купить 1,5 банда. Ну, никто вам их не продаст. Нет, вы можете договориться, вон, с Савиным, и сказать: Савин, тебе полбанда, мне 1,5. Пойдет? А?
Я больше по акциям.
Он больше по акциям? Ну, по акциям.
С пятерочки.
Хорошо. Он больше по... Сказать, с бандами вы не договоритесь. Там сзади еще Лиманов сидит у вас. Попробуйте с ним. Тоже не хочет. Еще дальше Зайцев. Ого. Так, окей. Okay, so I think everything is clear at this moment. We just had considered this situation, so everything is okay. And I think we can go to the next notations. This is about how to deal with this portfolio. So due to the fact that we're calculated the bond, the portfolio to a particular bond, we are able to calculate the internal rate of return of this particular bond. And this rate is called the internal rate of return of the initial portfolio. Everything is absolutely clear. You are calculating portfolio to a particular bond. you are calculating the internal rate of return of this bond, and as a result, you get what? You get the the internal rate of return of the portfolio. The second opportunity is to calculate the average yield. How it can be done? You can calculate the internal rate of return of a particular bonds. You can calculate weights of each bond in the portfolio, and you can summarize this rate multiple to the corresponding weights. And this will be so-called average or weighted average yield of the portfolio. These numbers are not the same in general case. They will coincide only if and only if all the bonds in the very beginning, when including in the portfolio, in case all of them have the same internal rate of return or yield to maturity. In this case, these numbers will be the same. Otherwise, they will be absolutely different. Okay? Ты что, умер? Не надо умирать. Еще 10 минут, потом можешь. Okay. So, now we going to the next notation. The next notation is duration at the convexity of the bond portfolio. I think everything is clear due to the fact we had recalculated bond portfolio to a bond. We can calculate the duration of this bond after calculating internal rate of return. We can calculate the convexity of this bond. And as a result, we will calculate direction and convexity of a particular bond. That's all. And this number represents the sum of the investment, and the sum of the investment, or the sum of the investment in portfolio, will represent the current price of the bonds corresponding to the portfolio. That is why here you have omega. Okay? Any questions at this moment? I told you that the omega represents the sum of the investment in your portfolio. After calculating your portfolio to a bond, omega will represent the current price of this bond. That is why here not P but omega. Did you understand me? Shall I translate? No? Okay. So this is about how to understand, and that is why I told you on the previous seminar, and I told you now that no need to consider a particular portfolio due to the fact we are able to recalculate the portfolio to a particular bond. Like a few minutes before, we can define the modified duration, the modified convexity of the portfolio. We just should adjust the duration and the convexity of the initial portfolio by dividing to the corresponding factors, like the duration and modified duration and modified convexity of a particular bond. But also we can make the notation about the weighted average duration and weighted average convexity of a bond, like weighted average rate. What should we do in this case? We should calculate duration and convexity of a particular bonds, which are the part of our portfolio, and we can multiply them on corresponding weights and summarize. As a result, we will arrive to the notation of the weighted average duration of the bond portfolio and weighted average convexity of the bond portfolio. Also, you can see on the slide the theorem that these actually the modified direction and modified convexity of a bond portfolio, both of them are approximately equal to modified duration and weighted duration of the portfolio and weighted convexity of the portfolio. You can see also the second part of the theorem, which tells us that if the term structure if the term structure of interest rates is flat, so it means the rates are the same for all the terms. If they are equal to the all time periods of investment, the approximate equalities turns out to be exact equalities. Did you understand what am I talking about? Yes or no? I will repeat. So this second part of theorem means that in case the rates for the investing for any time period will be the same, in this case, these approximate equalities turns out to be the exact. They just will be equal. Did you understand me? So no need to do it. So it means you just make use of the characteristics of a particular bonds to make to calculate the characteristic of your portfolio. Did you understand me? This is in this case, these equalities will be exact. In case the term structure is flat. Okay? This is a very important fact. Pay attention to this fact. But here must be written not time, but term structure. Okay. So now we can move to the next slide. Or are not able to move. We have to wait a bit, a few minutes. The last slide I want to reconsider that this is how to make an assessment of changing in price of the portfolio. So let us suppose the risk-free rate had changed slightly to delta R. In this case, the change in the portfolio price can be estimated using the following approximate equality. Okay? Now, how can we use, this is the last thing I want to tell you on this lecture. Pay attention to this part. Let us suppose we have the portfolio with same weighted average duration. How do you think using this equality, which portfolio is more attractive? We have two portfolios with same weighted average duration. Which portfolio will be more attractive? How do you think? Using this equality, which portfolio is more attractive? I can turn to Russian if you do not understand me. I'm assuming I have two portfolios with same weighted average duration. And I'm asking you, I have two portfolios, they have different convexity, but they have same duration. Which portfolio is more attractive to you if you are an investor? With I don't know, the sum of the investment will be the same, but you are choosing between two portfolios. I told you the portfolio has a K characteristic, duration and convexity. You have two of them and you should make the choice. But they have same weighted average duration and they have different convexity, different weighted convexity. With high convexity, but why?
Because there's a chance of higher profit.
Yes, why? The chance for higher profit.
investment is.
It will be more because the second part of the formula, it part has positive signs. Do you understand me? Shall I go to Russian? Yes. Смотрите сюда внимательно. Это изменение, это относительное изменение стоимости портфеля. Если у вас одна и та же дюрация, то у вас вот это слагаемое будет одно и то же. Соответственно, в каком случае вы заработаете больше? В таком случае, когда вот этот множитель у вас будет больше. Но этот множитель не зависит от портфеля, он зависит от изменения ставки. А вот это зависит от портфеля. Соответственно, чем больше этот множитель, тем больше вы заработаете. Понятно? Это то, как на практике применяется эта теория. Дошло? Отлично. И это то, что я буду спрашивать. И я вам один раз разжевала, а в следующий раз мозг будете использовать сами. Понятно? Ну что вы с таким лицом сидите, Шунейкина, еще никто не умер. А? В рамках кейса? В рамках кейса много чего надо будет посчитать. В рамках самого кейса вряд ли. Но в рамках защиты, скорее всего, да. Потому что защита кейса предполагает вопросы, Грачев. Понятно? А вот вопросы, это уже ваша жизнь усложнится. Окей? Так, все. До свидания.